I want you to imagine you're driving down North Comby Road.
Right, in Polk County.
Yeah, exactly. Polk County, Florida. You're cruising past, standard retail strips, maybe a few modest warehouses, and then you spot it
The vacant shell building.
right there at 610 North Comby. From the street, it just looks like a simple rectangular concrete box, completely empty, around 3,800 square feet.
Just a standard vanilla box.
Right. Now, I want you to imagine turning that empty box into a modern, high-production laundromat. If you're like most people looking for a business venture, you are probably picturing the ultimate passive income dream.
Oh, for sure. You picture it like sweeping the floors, hooking up a row of washing machines, setting up some folding tables, and just
Sitting back and collecting the money.
exactly. It's incredibly common to view it that way. You picture a few heavy-duty water hoses, some extension cords, maybe a coin change machine in the corner, and you think, well, I'm a business.
Well, we are going to completely dismantle that myth today. The mission of this deep dive is to explore the wild, architectural and technical complexities of converting a bare retail shell into a commercial laundromat.
It is not what people think it is.
Not at all. By the time we're done, you're going to see why a modern laundromat is not actually a retail store. It's a high-powered industrial utility plant hiding in plain sight.
Yeah, and to pull the curtain back on this, we're looking through a massive stack of sources specifically tailored to this exact property in Polk County.
Which is super helpful because it gives us real numbers.
Right. We're talking about comprehensive architectural specifications, highly detailed MEP engineering guidelines.
That's mechanical, electrical, and plumbing, right?
Exactly. Plus the strict Florida Building Code feasibility reports that govern, what you can and absolutely cannot do to a building in this state.
So I was looking at that empty box on Comby Road thinking, a coat of paint, maybe some plumbing. But when you dive into those feasibility reports, the whole plug-and-play fantasy just entirely evaporates.
It really does.
What is it actually going to cost to get some washing machines running in this space? I mean, what are the numbers?
Well, if you look at the estimates for this specific 3,800 square foot shell, the renovation and equipment costs alone are projected to land anywhere between $760,000 and $1.6 million.
Wait, I need to stop you right there. Up to $1.6 million.
Yeah.
Just to put washing machines in a room. If someone wanted to put like a clothing boutique or a greeting card shop in that exact same building, it would cost a fraction of that.
Tiny fraction, yeah.
So why is the budget pushing almost $2 million? That's insane.
The difference comes down to a concept called the utility core. I mean, if you build out a clothing boutique, your infrastructure demands are minimal. You put up some drywall, install some nice track lighting.
Frame out a single ADA restroom, maybe?
Right, and run a standard commercial AC unit. But a laundromat has an entirely different anatomy. The MEP engineering, like we mentioned, the mechanical, electrical, and plumbing, that acts as the actual engine of the business.
It's not just furniture.
Exactly. You aren't just placing appliances into a room. You are building an industrial-scale infrastructure to handle massive physical forces and, frankly, unbelievable resource consumption.
Thinking of this as a retail store is like comparing a garden hose to a city fire hydrant.
Yeah.
Which makes sense when you look at what is actually going inside. It isn't just a couple of washers.
Not at all. The floor plan for this space calls for an army of machines. We're talking about 30 commercial washers and stacked gas dryers.
And we need to be clear about the types of machines these sources are highlighting, right? These are not the washers sitting in your garage.
Oh no. The plans call for mega load machines. These are 80-pound industrial extractors designed for massive comforters or huge family loads.
Wow.
And a single unit can cost upwards of $18,000.
18 grand. So the appliances alone are a massive capital expenditure right out of the gate.
Huge. But the appliances are just the tip of the iceberg. Those mega load machines are incredibly hungry. They consume utilities at a terrifying rate.
Which is where that 1.6 million comes in.
Exactly. The reason the budget gets that high is that the building's existing guts are entirely inadequate to feed them. You essentially have to build a specialized factory inside that hollow concrete shell.
Let's pop the hood on that factory and look at the engine, because water and air are the absolute lifeblood of this operation. The sources identify plumbing as the primary cost driver of the entire project.
It is the biggest hurdle, by far.
I imagine a standard bathroom pipe isn't going to cut it.
Not even close. In a standard retail space, you might have, say, a 2-inch sewer line to handle a basic toilet and a break room sink.
Right.
But the Florida Building Code,
Yeah.
Specifically, Section 406.3 mandates a massive upgrade for this kind of facility.
What kind of upgrade?
Well, to handle the volume, you're looking at saw cutting and tearing up the existing concrete floor just to install a 4-inch main sewer line paired with a dedicated 2-inch potable water supply line coming into the building.
Tearing up the concrete. Because these machines are pulling hundreds of gallons of water per hour. But getting the water in is one thing. I was reading about the drainage, and it is fascinating. You don't just run a PVC pipe from the back of the washer to a drain hole in the floor.
You couldn't, even if you wanted to. Think about the mechanics of what happens when the wash cycle ends. You have to size your drainage to handle a worst-case scenario.
Well, like all of them emptying at once.
Basically, engineers typically design the system assuming that 75% of the entire laundromat's machines will empty their water at the exact same simultaneous moment.
That is a lot of water.
It's a flood. If you tried to force all that sudden wastewater through standard PVC piping, it would create an immediate bottleneck.
Like backing up into the store.
Instantly, your entire customer floor would be under an inch of water in less than a minute.
So how do you physically move that much water that fast if pipes don't work?
These machines actually discharge into massive custom-built concrete drain troughs.
Wait, so you are building a literal indoor concrete river behind the drywall?
That's exactly what it is, a concrete river.
But it's not just clean water flowing down that river. You run into a major municipal hurdle here. The Florida Building Code, Section 1003.6, is incredibly strict about what happens when that water actually leaves your building.
Because commercial laundry wastewater is a nightmare for city infrastructure. It is packed with lint, strings, loose buttons, even coins.
Stuff that destroys pipes.
Exactly.
Mm.
If you flush that directly into Polk County's sewer system, the lint fibers weave together with soap scum and minerals to create blockages that are basically as hard as concrete.
Oh, wow.
So the code requires the installation of a specialized lint interceptor.
How does that actually work? Does it act like a giant coffee filter for the building?
Essentially, yes. It can take the form of an exterior vault buried outside the building, or a series of large removable wire baskets inside the troughs themselves.
And the code is specific about those baskets, right?
Very. It mandates a maximum half-inch mesh on these baskets. They physically catch the debris before it ever crosses your property line.
And if you don't keep them clean?
If you fail to maintain it, the county can actually test your wastewater via a sampling manhole.
A sampling manhole.
Yeah, they pull your water and test it. And they can hit the business with crippling surcharge fees for damaging the public sewer.
That is wild. Okay, so we have a massive indoor river handling the water. But because you are washing hundreds of pounds of clothing, you end up with hundreds of pounds of soaking wet, heavy laundry.
Which means a lot of moisture.
Right, that moisture has to go somewhere, which brings us to the air. You have 20 to 25 industrial gas dryers to evaporate all that water.
And to get that hot, moisture-heavy air out of the building, they use rigid 8 to 12-inch galvanized steel ducts to exhaust it to the outside.
But this introduces a massive aerodynamic problem. The sources point to Florida Building Code 504.5, which mandates something called a makeup air system, commonly called an MUA.
Right, the MUA.
I read that section, and I have to admit, it made me slightly alarmed.
Hmm.
If you have 25 industrial dryers constantly sucking thousands of cubic feet of air out of a sealed, air-conditioned Florida building,
Yeah.
and you do not pump fresh air back in to replace it, do you literally create a vacuum inside the store? Does it trap your customers inside because the negative pressure makes it physically impossible to push the front doors open?
I mean, it sounds like a premise for a disaster movie, but yes, you absolutely create a vacuum. The phenomenon is called negative pressure.
That is crazy.
The fans in those dryers are incredibly powerful. If you don't have a properly engineered makeup air system actively pumping fresh air back inside, the vacuum will pull so hard on the building envelope that the doors will essentially suction shut.
Trapping people inside.
Yeah, but trapping customers is actually the least of your worries. Negative pressure causes a much more deadly issue called backdrafting.
Okay, wait. How does backdrafting work? What is actually happening in the air?
Remember, these are gas dryers. And you also likely have a massive commercial gas water heater humming in the back room to supply that 2-inch water line.
Right.
Both of those systems burn gas and produce toxic exhaust, including carbon monoxide, which is supposed to drift up their flues and vent safely out of the roof.
So what happens with the vacuum?
Well, if the building is starving for air because of the dryers, the vacuum will look for air anywhere it can find it. It will actually overpower the natural draft of the flues.
Oh, no.
Yeah. It pulls that toxic exhaust gas and carbon monoxide backward, down the pipes, and directly into the customer area.
That is terrifying. You are essentially turning the laundromat into a gas chamber just by drying clothes. How do you engineer a system to prevent that safely?
The building code requires that the makeup air system must be technically interlocked with the dryers.
Interlocked, meaning they communicate.
Exactly. You can't just rely on an employee to remember to turn a fan on. The MUA intake fans must automatically trigger the millisecond the dryers ignite.
Wow.
The building has to mechanically breathe in perfect synchronization with the appliances.
The coordination there is incredible. But moving all that air and water requires incredible physical force. We talked about those 80-pound mega-load washers earlier. When they get to the end of a cycle, they have to extract the water from all those heavy blankets.
And the extraction cycle on an industrial washer is violent. To pull the water out of the clothes, these machines spin at incredibly high speeds.
How fast are we talking?
They generate anywhere between 200 and 400 Gs of force.
So the architect isn't just placing furniture on a floor plan. They're basically designing a foundation to anchor a theme park ride indoors.
That's a great way to put it. If you simply bolted an 80-pound industrial extractor to the standard 4-inch concrete slab that came with that empty retail building.
The original floor.
Yeah, the sheer G-force would cause localized earthquakes. It would literally shatter the concrete beneath it.
So the original floor is useless for the heavy machinery.
Completely useless.
Yeah.
The structural engineer has to design a 6 to 8-inch thickened slab.
Wow.
The construction crew has to saw cut the existing floor, dig down into the dirt, and pour a massive new concrete pad reinforced with extra steel rebar, specifically mapped to where the megaload machines will sit.
It's essentially building an underground bunker just to keep the washing machines from tearing themselves apart.
Exactly.
And to power that violent spinning, you need serious electrical juice. I know a standard wall outlet isn't doing the job.
Not even close. The engineering notes indicate the building requires a massive service upgrade, bringing in anywhere from 400 to 1,200 amps.
1,200 amps.
Yes. And crucially, it requires three-phase power.
Why three-phase power specifically? What makes it different from, like, the electricity running to my house?
Well, standard residential or light retail buildings usually operate on single-phase power. Think of single-phase power like a single person pushing a heavy merry-go-round. They push, the momentum drops slightly, they push again, it pulses.
Okay, that makes sense.
Three-phase power is like having three people equally spaced around that merry-go-round, pushing in an overlapping sequence. The power never drops to zero.
Oh, so it's a constant push.
Right. It provides a consistent, continuous flow of electricity, which is absolutely mandatory to run those heavy-duty industrial motors efficiently without burning them out from the constant starting and stopping strain.
And beyond the brute force, there is a delicate technological side to the electrical engineering, too. The sources highlight the need for specialized grounding specifically for the payment systems.
Yeah, because modern laundromats rarely rely just on quarters anymore. These machines are equipped with Bluetooth modules, Wi-Fi connections, app-based card readers.
Right, nobody carries coins.
But the problem is, dozens of giant industrial motors spinning simultaneously create massive electromagnetic fields.
Oh, I didn't even think about that.
If the entire electrical system isn't grounded perfectly, that magnetic interference will scramble the card readers, and nobody will be able to pay for their wash.
Which brings us to what has to be the most stressful part of the architect's job. You have thickened concrete bunkers, giant drainage troughs acting as rivers, heavy electrical conduits carrying three-phase power, and high-capacity gas manifolds running to the dryers.
It's a lot of infrastructure.
And all of this has to fit into a tiny space.
They're usually fighting for space in a utility corridor behind the machines that is only about 4 feet wide.
4 feet?
Yeah. This is where 3D coordination becomes critical. The margin of error is basically zero. Imagine a contractor is on site and decides to shift a row of washing machines just 6 inches to the left to make room for a trash can.
I mean, a 6-inch change doesn't seem like a big deal in an empty room.
But it triggers a domino effect of catastrophic failure. Suddenly, the electrical nodes drop from the ceiling in the wrong spot. The gas manifold connections are out of reach. And worst of all, the massive extractors are no longer sitting perfectly over the structural thickened slab. They are sitting on the weak 4-inch concrete.
And they tear themselves apart. This perfectly explains why the sources emphasize a step called phase zero. Before anyone even touches a sledgehammer, the architect has to use lasers to map the exact locations of every existing pipe, beam, structural footing, and wall.
You have to know the exact anatomy of the empty box before you try to stuff a humming utility plant inside it.
Because if you just guess and you find out during construction that your new 4-inch sewer line won't fit past an existing structural footing buried in the dirt,
Your budget just exploded.
let's assume you get the engineering right. You map the space, you pour the thickened slabs, you install the interlock makeup air system, and you coordinate the three-phase power perfectly.
A miracle in itself.
Right. You still have to face the final boss of the operation. If it doesn't pass Polk County's strict legal and safety codes, you will never open your doors.
The code maze in Central Florida is intense. Let's start with the Florida Building Code's wind load requirements. We talked earlier about pumping makeup air into the building and exhausting the hot, drier air out. Yeah. To do that, you have to install giant exterior louvers.
You are basically punching giant holes in the side of a sealed concrete box.
And the building inspector is very aware of that. Because Polk County sits in a hurricane zone, every single louver, every vent cover, every new storefront window you install must have a specific Florida product approval number.
It's heavily regulated.
Highly regulated. It has to be legally certified by an engineer to withstand 135 to 140 mile per hour hurricane force winds. You can't just buy a nice-looking vent cover at a local hardware store. It is a structural defense mechanism.
And once you step inside the building, you are navigating the ADA, the Americans with Disabilities Act. It's not just about slapping a wheelchair ramp near the front door.
No, the ADA dictates the spatial geometry of the entire customer floor. It is a massive puzzle for the architect. Well, the layout must feature strict 48-inch aisles. This isn't just a suggestion. It ensures a wheelchair user has total maneuverability, or that two customers pushing bulky laundry carts can safely pass each other without creating a bottleneck.
The sources also specified the folding tables have to be exactly 28 to 34 inches high to ensure proper knee clearance.
Yep.
You even have to install those truncated domes, the bumpy yellow pads you see on sidewalks, on the exterior parking ramps, just to get from the asphalt to the front door safely.
Every square inch of the 3,800 square feet is legislated.
But all of those building codes, the hurricane specs, the spatial geometry, they pale in comparison to the financial hurdle of the municipal impact fees.
Oh, the impact fees.
I was absolutely floored when I read this section. Explain how Polk County calculates these fees, because it seems completely wild.
So Polk County charges municipal impact fees based on a metric called Equivalent Residential Connections, or ERC.
Okay, what does that mean?
The city calculates the projected daily water and sewer usage of your new business, and they figure out how many standard houses your laundromat equates to in terms of utility strain.
Wait, so because a 3,800 square foot laundromat processes an absolute ocean of water compared to a normal retail store, how much does the city actually charge you just for the right to connect to their pipes?
The city impact fees alone. Just the check you have to write to the county government for the right to turn on your water and connect to their sewer system can cost the owner anywhere from $20,000 to over $50,000.
Depending on the machine count.
Exactly.
Are you kidding me? Over 50 grand just for permission. Before you've even bought a single washing machine or poured a single ounce of concrete.
Yes. The city has to process all that wastewater, so they charge you up front for the immense strain you are adding to their municipal infrastructure.
It totally recontextualizes the role of the architect here. I mean, between a $50,000 hit for impact fees, having to rebuild the concrete floor from scratch so the machines don't shatter it, and upgrading to a 1,200 amp three-phase electrical service.
It adds up fast.
Is this why they insist on that phase 0 feasibility study? Is their primary job actually just stopping an investor from accidentally buying a building that is financially impossible to upgrade?
When you synthesize all the data, yes. The architect's job on a project like this is fundamentally risk management.
Wow.
They're not just picking out nice floor tile or making sure the space looks bright and airy. They are performing a high-stakes feasibility study. They have to translate industrial water flow, dangerous thermal dynamics, and massive electrical loads into a language the city inspector will actually approve.
They're the translator.
Exactly. They are the final line of defense, saving the owner from catastrophic fines, structural failures, or, sinking their life savings into a building that physically cannot handle the demand of a commercial laundromat.
It really makes you view the built environment completely differently. You walk into that space on Combi Road, and to the naked eye, it looks so delightfully simple.
Right. Clean floors, humming machines.
Comfortable air conditioning. You easily tap your phone to pay, throw a giant comforter in the wash, and sit back to read a book. But beneath your feet, behind the drywall and up in the ceiling, there is a marvel of hidden MEP engineering, structural fortitude, and strict code compliance working flawlessly together to keep the building breathing and standing.
It is a finely tuned industrial factory, perfectly masquerading as a local retail shop.
We tend to judge buildings by their storefronts, by their paint jobs, or by the glowing sign above the door. But if you peel back the layers of our modern conveniences, whether it's a laundromat, a neighborhood coffee shop, or a sleek data center, you realize that our entire world is actually dictated by the invisible math of plumbing troughs, interlocked exhaust ducts, three-phase power grids, and the local building code.
It's all hidden in plain sight.
So the next time you are out running errands, take a look around. What other hidden industrial engines are you walking past every single day without even noticing?